critical temperature, critical pressure, and eccentric factor of dry air. So, how to calculate the critical temperature, critical pressure, and eccentric factor of dry air? This is a pressure versus temperature diagram for mixture of the gases. So, main properties of gas involves are critical pressure, critical temperature, and eccentric factor. Critical pressure is defined as a pressure at which liquefaction of gas is done at critical temperature. Critical temperature is defined as a temperature above which liquefaction of gas is not possible, no matter how much pressure is increased. It is noted that above critical point, gas cannot be converted into liquid. Eccentric factor is a property of gas which measures the non-sphericity or centricity of the molecules, and due to this, boiling point gets elevated. Eccentric factor takes care of this. That means each gas component has a certain value of critical pressure, critical temperature, and eccentric factor. To find out to find these properties of gas mixture, mole fraction of each gas component is multiplied with these properties and add them up to get the properties of the gas mixture. So critical temperature, critical pressure, and eccentric factor. This is a chart or table. This can be referred for calculating these properties for mixture of the gases. Now steps to be followed for critical temperature, critical pressure, and eccentric factor for dry air. Find out the mole fraction of each gas component, multiply the mole fraction of each gas with its critical temperature and add them to get the critical temperature of the gas mixture. Multiply mole fraction of each gas with its critical pressure and add them to get the critical pressure of the gas mixture, that is dry air. Multiply the mole fraction of each gas with its eccentric factor and add them to get the eccentric factor of gas mixture, that is dry air. Now dry air composition is, we know all the, it is given in percentage by volume, all the gases for the dry air. So A column is given, mixture is 100, summation is 100%. Then B will be A divided by mixture, which is a mole fraction. C is the critical temperature, then multiplied A into uh, sorry, A multiplied C, sorry, B multiplied C will be D, which is a critical temperature of the mixture. Adding all, this will give the critical temperature. Similarly, E is the critical pressure, multiplied B into E will give the columns F, which is a summation of all these will give the critical pressure of mixture. G is eccentric factor, multiplying B into G will give the eccentric factor, and adding all will the eccentric factor of the mixture. So critical temperature of dry is 132.44 degree Kelvin. Critical pressure of dry is 37.064 bar absolute, and eccentric factor of dry is 0.036. Hope you have enjoyed this and you know how to calculate the critical temperature, critical pressure, and eccentric factor of dry air. So thank you for watching.